So let me just welcome Tom Ferlani and Bob Dwan from University of Buffalo, giving us a presentation today on XDMOD. And I will just turn it over to you, Tom, to go ahead and introduce your subject further.
Okay, so today we're going to talk about XDMOD, which stands for XD Metrics on Demand software we've developed. There's a version that runs on XSEED resources, so for the campus champions, they can access it. That data's maintained locally here, and then through XDMOD you're allowed to, and you'll find out through this demo hopefully, a lot of the different options you have for analyzing the data, looking at usage, and we'll focus on the job viewer demo, where basically you can interact with your users on campus who are running on XSEED resources and be able to provide detailed analysis of their jobs. And just as a brief introduction, for example, we run it here at our center. We have a local version too, and we oftentimes find users that think they're running in parallel and asking for 12 nodes, and it turns out their code was sequential, and that happens all the time at academic supercomputing centers because you have such a large number of users. You don't interact with them directly. They inherit a code from somebody else who inherited it from somebody else, and so we found it to be a useful tool not only to identify poorly performing jobs and recover CPU cycles, but also for some of the more sophisticated users to also help analyze their codes and see how we can make their jobs run more efficiently. In addition to the version that runs on XSEED, which is called XDMOD, there's a version that runs on academic centers called OpenXDMOD. And so I know many of the campus champions also have academic supercomputing centers on their campus. So whatever we're doing here, you can do on XSEED, and you don't have to do much in terms of installation, but if you want to install OpenXDMOD on your system, you can have the same functionality that we'll talk about today. So I'm going to start with a brief overview, and then Bob Dwan is going to actually do a demo, and it's fully interactive, so if you have any questions, just let us know. If you'd like to see something, Bob do different types of plots, let us know. I'll start with the service team. It's a combination of folks from UB, many of them are in this room here that you can't see. Indiana, who does scientific impact type analysis. TAC, who Bill Barth, Todd Evans, Jim Brown, who are involved in the job level performance data analysis that we'll be talking about for the majority of this talk. And then we're working with NCAR, and we're thankful for National Science Foundation funding. So XDMOD, as you mentioned before, it stands for XD Metrics on Demand. It's developed for NSF to support, as I mentioned before, the XSEED supported, or their supercomputer portfolio. So it's running on XSEED resources, the service providers. Also, Blue Waters is running an instance of the OpenXDMOD, and NCAR is running an instance of OpenXDMOD. And as I mentioned before, there's an open source version which is for academic high performance computing centers. It has three different components I like to think of. One is the interface, which is you'll see a lot of that today, and you can easily look at utilization, performance, quality of service, which is also important, and which I'm going to talk about in a second. So there's the interface, which is we hope to be easy to use. We're working on making it more usable. Then there's measuring quality of service. We run things called application kernels that detect poorly performing or underperforming hardware and software. A good example of that is at our own center we had a file system, commercial file system that was had a bug in it, and it was only discovered by running an NWChem-based application kernel that detected a bug in the parallel file system. It would have gone undetected. Users that ran that particular job, sometimes the job would fail, sometimes it wouldn't, and it would have just gone on, and nobody would have ever identified it. But like I said, with these application kernels, we look at quality of service, and so we want to know ahead of time when software or hardware is underperforming. And then the majority of the talk has been talking about measuring the job level performance for every single job that's running on the cluster without the need to recompile the jobs. Oh, all right, I'm ahead of myself. So again, the XDMOD portal provides detailed metrics, utilization, quality of service, scientific input, impact. Bob's going to go over the interface quite a bit today, but it's role-based. So if you're a user, you see your jobs. If you're a PI, you see your jobs plus everybody that's underneath you. System administrators can see all the jobs and analyze everything going on at their particular center, same as a center director. And then a program manager, for example, such as John Towns for XSEED, he'd be able to see everything that's going on at all the different resource providers. And the nice thing about it, it has a custom report builder, so you don't have to log into the interface every single time to, like for example, in the Campus Champions, if you wanted to know what the people on your campus were doing, you could just go into the custom report builder, say these are the types of plots I want to see, and I want to see them every month, every quarter, every year, and it would automatically email you whatever type of file you want, a PDF, a Word file with plots in there, and so then you could just periodically receive those, and you know, like I said, whatever metrics you're interested in reporting on, you could have at your fingertips. Okay, so here actually is the example I talked about, the quality of service. The idea is to proactively identify poorly performing hardware and software. I like to say the user shouldn't be the canary in the coal mine identifying problems. So with application kernels, they're computationally lightweight. They run every single day or every other day, depending on the frequency you want to schedule them, and it's running the exact same series of jobs. So in this case, this particular job is an NWChem. It's running on 8 cores or 8 nodes, I forget which in this example, and then running on 16, running on 32. It runs for a relatively short period of time, 10 minutes or less. And so if it's running the exact same job every single day, the execution time should be the same. And you can look in this for 8 cores, the execution time was flat. It's under 100 seconds from May, June, and July. But we had widely varying behavior for 16 cores. Sometimes the execution took much, much longer. Other times, anyway, it just varied widely. It turns out there was a bug in the Panasys file system. When NWChem went to check to see if a file system was available to write on, for some reason it would hang sometimes and it wouldn't come back, take a long time to come back. And it took us a while to track it down. Once we did, we contacted Panasys and they released a patch to their parallel file system that went not only to us, but to other users. The point in all this is if you're some poor user that's submitting that NWChem job, your job's going to fail or take longer to run, you're not going to try to figure out why. You'll just resubmit another job, or the next day you'll submit another job and just hope it runs a little bit quicker. And the system support personnel don't have the time to be looking at all this every day. So with this particular software, you would receive a notice, the system support personnel, that the execution time is out of the 3 standard deviations from the norm or whatever preset tolerance, and then you could go investigate it. And then the last thing we're going to talk about is job level performance. And as I mentioned before, the idea is to improve cluster throughput. They're oversubscribed as resources as they are, identify poorly performing jobs, and then work with the end users to help make the jobs more efficient. We have, as I mentioned, an instance running here at our center. Our HPC support specialist uses this tool absolutely every day to look at users' jobs, failed jobs, or users that contact her, and try to analyze them and determine why they failed, and for those jobs that aren't performing very well, what we can do to make them perform better. And sometimes the solutions are really simple. The code needs to be built in parallel. Believe it or not, that happens quite frequently, unfortunately, on a lot of HPC systems. And here's an example, and I'm not quite sure. It was run at our center, but if you look at the plots, on the left-hand side is before as the code was running prior to us analyzing it, and out of the 10 or more nodes, none of them were over 40% in terms of CPU usage. And like I said, I forget what the details of this particular run, but after working with them, if you look at the plot on the right, on 4 nodes, they were able to achieve 100% CPU user. And so these are the type of jobs that you can pretty easily identify with the software that we're going to describe here, and that's the real reason, and that's the motivation for this project. And then again, just to give credit where credit's due, it's a collaboration with Texas Advanced Computing Center. It's an integration of XDMOD with monitoring frameworks. So in terms of XSEED, most of the resource providers have installed TaxStats and Lariat to collect application data and job level performance data. But if your particular center uses a different monitoring framework, we happen to use Performance Copilot, and we're working on integrating Ganglia with NCAR. You can use those. It'll be ingested in XDMOD, and you'll be able to provide performance data, as I mentioned before, for every single job that runs on your cluster. You look at things like memory, local I/O, network, file system, CPU usage, those sorts of things. And it does that by collecting detailed information from their hardware counters on the nodes. And so, as I mentioned before, you don't have to rebuild your codes. The users don't have to do anything. You kind of get the information for free, and it doesn't impact the overall performance of the application codes. We run it every 10 seconds, I think, here, collect the data, and we've noticed no measurable real impact on the user's performance. So it's available in Open XDMOD, like I said, for HPC centers, and I've already gone over a lot of this stuff before, but you can flag jobs for idle nodes, node failure, high cycles per instruction, all of which are not necessarily good, and sometimes there's a reason for it, most of the times there isn't. And then, like I mentioned before, we use it every single day here. And this is just for you campus champions. It's running on TAC, Lone Star, Stampede, Wrangler, Maverick, SDSC, LSU, NIC Starter, TSC. They're planning it for Bridges, so we're going to be working with them soon, and then some of the other non-XSEED sites. And Bob's going to go over this interface. We have a nice tool called the Job Viewer, which provides you with detailed information, analytical capability for any job that you're interested in. You can search on jobs, you can search on categories of jobs, but I'm going to let Bob describe that in a second. So I'll stop here and I'll ask if there's any real quick questions, but I know that was a brief overview, but I wanted to give Bob a lot of time to go through a live demo, and he's got a planned series of things he's going to go through. But at any time you can ask a question, or if after I think he's done with his demo, if you want to see some other analysis, we can do those sorts of things on a particular system you're interested in. Are there any questions? Okay, we'll move over. This is Bob DeLeon.
Okay, Tom, thanks. Tom has given you the big overview, and I'm going to give you the worm's eye view of the thing now. Here we'll actually get down and actually use the thing live, because of course this is the obligatory outline of what I'm going to do. I'll present a brief demo of XDMOD in general, make some charts and show you how to do that. I'm not going to try to get into detail about how to make all of the charts and all the wonderful things it can do. It's just going to be a very surface demo. Then I'm going to talk about mostly on the Job Viewer tab. We'll look at a few of the jobs in there, do that, and then show you some different ways to do job searches. And as Tom said, we're going to try to make this interactive as we can. All right, let me go down and just briefly re-mention some of the things that are key for the Job Viewer. The metrics in there come from the Supreme, what we call Supreme performance metrics, and they come from either the TAC stats or the performance copilot. Basically, we're looking at the counters, and we've got metrics on practically everything you can think of, and in general categories: CPU, I/O, memory, file system, network, etc. We try to do application identification when we can, and the overhead is fairly small for those people who are interested in installing OpenXDMOD in their own system. Okay, so I'm not going to need that anymore.
Should go over that, Bob.
What? What? I'll talk about this at the end, I guess. All right, I got to get back to my other. Now here's where we see how well this stuff all works. I've got to log on to XDMOD. It's always fun trying to do a live demo. You never know what's going to come up. In this case, I'm going to be working with the developer version, so that adds another level of excitement to it. And finally, one more level of excitement. This whole thing, our entire computer system essentially flatlined yesterday because of power outages. So we're going to be trying something that was just reinstalled yesterday. So with all that in mind,
So our job level performance data from yesterday is pretty easy.
let's hope for the best. Okay, I just logged on to using my XDMOD credentials, and you can actually log on using XSEED credentials. But if you're a campus champion, you probably want to talk to us and apply for to get XDMOD credentials so that you can see other people who are running under your allocation. And the way to do that is to hit the Contact Us button up here and send us an email and tell us what you're doing, and we'll issue you the proper permissions. What you're looking at right now is the summary page in XDMOD. And the way you get around XDMOD, the way you navigate around is you use these tabs. And I'm not going to go through all of these tabs and what they all do and all that. But I'm going to be showing you the usage tab, which is basically used to make data exploration plots. You can make a real simple plot with the usage tab. You can, if you want to dive down in deeper, you use the Metric Explorer. There you can compare different metrics and do things much more in more detail. You can change the display with more, you have more capability to change the display. Tom talked about the application kernels. I'm not going to. There's the report generator. Tom mentioned that, and maybe I'll give you a quick show how to do that. Also, the main thing I'm going to talk about is the job viewer. And while I'm talking about all this stuff, up here is in the help button. If you push that, you'll get our document with the user's manual, which is more or less up to date as of the last release, which is pretty good. We also have a roadmap button, which tells us where we're going, and you can click on that. And I'm not going to do that right now, but if you do that, you can see what the development roadmap is, and you can also make feature requests. Let's get down to try to actually making a plot in XDMOD. If you push the usage tab, you'll note on the left here there's a tree here where a bunch of different metrics are shown. They're grouped. The metrics are grouped by what we call realms, which are similar metrics. And I'm going to click on the supreme, or the performance realm. If you want to make a simple plot, I'm going to make a very simple plot. I'm just going to click on the number of jobs ended in the performance realm. With one click, you can make a plot in XDMOD. There it is. You are now looking at all of the XSEED jobs that were logged in the period from 5/1 to 5/31, so it was last month. You can select that. Oh yeah, the dates are over here. There's the date selector. There's two ways you can select dates. One is the pre-selected drop-down menu where you can grab whatever you want, previous month, quarter to date, whatever. Right now it has the previous month is selected in that. Or you can directly change the dates. Like for example, if I want to select from 4/1 to 5/31, so in other words, that would be the previous 2 months. I can select that. I can change the start date, the end date, hit refresh, and then I'll have a new plot, which gives me the data for the number of jobs ended for all of XSEED in that range. So the Usage Explorer is good for making very quick plots if you just want to look at do data exploration. Now, the Metric Explorer is the one that most people use when they want to do a finished plot. And there's different ways you can do that. One thing you can do is just click on this little gear over here, and that will reconfigure your plot, a usage plot in the Metric Explorer. And then you can, if you will, you can put another metric in there. For example, if you want to compare CPU hours to jobs run, I just click on that, and I'll now have a comparison, essentially, there it is, between number of jobs that are run and the CPU hours for those jobs. So the Metric Explorer gives you a lot more detail and all that. So let's generate a chart from scratch in the Metric Explorer. You'd click in a new chart. Let's make a chart that's a bar chart that shows all of the jobs by, say, institute. I can put that in as the chart title. I'll click on that, and then I'm going to click on my chart tree over here. I'll make the same number of, just look at jobs ended again, to keep it easy. Hello. Okay, and now I'll group by the user institute, and I should get a bar chart that shows the all of the particular jobs by institute. And so that's that's the kind of general approach that we use. I'm not going to go in and show all the details about how you can change things. You can do drill downs by, let's see, where is it? If you click on this, you can do drill downs for all the, a whole variety of different metrics for that particular thing that you've chosen. You can add filters. You can filter by all these different metrics, and so on. And later on I'll go through and do one more complicated thing where we actually filter and drill down and select jobs for the job viewer at the end if we have time. Okay. So that's my quick and dirty nutshell version of how to use XDMOD. And now I'm going to go and actually get into the job viewer. I just clicked on the job viewer tab, and then I clicked on search, and this brings up the screen that allows you to search for jobs in the job viewer. Now there's three basic ways you can do for searches in the job viewer. Is that too hard to see? Okay. I'm going to show you all three of them. I'm not going to spare you on that. And the simplest one is if you know what job you want to get and where it is and where the job was, is to just select the resource and a job number. And in this case, I've got one that I've already pre-selected that I want to show.
There's a question.
Oh, okay. What's the question?
Is it possible to get data on different time resolution per hour or per several hours instead of per day?
The time resolution, we have different aggregations, but unfortunately the minimum aggregation is by day. You can aggregate by day, month, quarter, and year that I know of, but it's intended only to essentially. The way it's done, it's a batch input. At least for the XSEED version, what happens is the data gets reported to the central database, and then we ingest it in the evening. We do our aggregation, which allows us to do the queries quickly when you push the buttons, and so the data is essentially ingested in a batch, and then every day you'll get the data from the previous day. Now, the only caveat is that we can only display data after it's come to us from the central data, from the XSEED resources, which sometimes is a lag in that report, and so sometimes it's a couple of days before you actually can display a given data set. What we're working on is we're going to, with the OpenXDMOD, you can of course ingest it more frequently, and if you have your own instance of OpenXDMOD, you can actually improve that turnaround, but that's not presently possible for the regular Xseed version. Okay, so I was starting to show you how the simplest way to do a job search, which is enter the resource, the job number, and hit the search button. And what happens is you get that job. There it is. Okay, there it is. It's okay, I already have that saved, but okay, so anyway, that appears, then that job will appear in the search history here. And so you can put jobs in the search history, and you can keep them and look at them later. You can compare them with other jobs, etc. Right now, I just put this particular job in, this TAC job, and I'll open it up and I'll show you the kind of information that you can get out of that. So across the top you have these traffic light displays. The left one is the CPU user balance. So what that looks at the relative amount that each core spends in the CPU user mode. In this case, the balance is awful, which indicates that probably some of the CPUs are not working, not doing anything at all. The homogeneity indicates how uniform the execution is throughout the time frame of the program. In this case, this program is fairly uniformly executed throughout. That's the good news. The bad news is the execution, the CPU user overall is only a few percent. So it's not really doing much. It's consistently not doing much the whole time. In the accounting data tab shows you accounting data type information, who ran the job. This particular job was run on 256 cores, 16 nodes, etc. We don't know what application it was, and it happened to run for about 19 hours. If you click on the executable information, for this one we don't have a whole lot. In fact, we're not able to figure out what application was being executed in this particular case. Summary metrics gives you an overview of what's going on with the CPU, block devices, network, etc., etc., etc. I'm not going to go in through all that. And then detailed metrics, you can dig down even deeper. And like if you look at, for example, the CPU, you can look at the various CPU, idle, I/O wait, nice, soft IRQ, etc. And then there's a whole bunch of statistics on that, stuff, average, standard deviation, median, and the whole scheme of moments there. The more fun stuff to look at is the pretty pictures, and we'll show some of those here. This is the CPU user chart for what's going on the 16 nodes here, 256 cores. And you can see that one node here, this one is just putting out a few percent CPU and user, and all the rest of them are flat lines. If you look at this one that's doing something, you can see basically one core is really doing great. It's running more or less 100%, and every other one, if you look at it, you're getting nothing. And if we look at the other nodes, zero, pretty much 0%. So this is basically a job that's running on one core out of 256 cores that were requested.
an exceed job.
This is an exceed job. The other thing you can look at is the homogeneity we get from the L1 cache D loads, and so we can look at that. It's fairly uniform across the range of the whole time range of the job. Sometimes jobs will go out and get off to a good start and die later. We'll show you one of those next. And then, of course, there's other things. There's the memory bandwidth. Again, one node is doing all the work, one core is doing all the work, and everything else is taking a vacation. The memory usage shows both the process and all the system usage. So all the cores are sort of basically just doing system work.
Well, this is a pretty egregious example of one core out of 256. There's more subtle times. For example, using this, we found a case where Stampede jobs were running at 75% utilization, CPU user, and it turned out when you did investigation, the user had been running on Lone Star, which had 12 cores per node, and didn't change a parameter in the submit script, and so when they submitted the jobs to Stampede, they were still only they were only running on 12, even though Stampede has 16 cores. So that's a more subtle case in which you could recover 25% of your CPU cycles, and my suspicion is that happens quite a good bit because not everybody is up to speed on, first of all, the changes in the new architectures, and second of all, they're just used to, maybe it's a student that joined the group late and is just using his previous script. And so the point in all this is sometimes there's really egregious, which are, easy to find, and other times there's more subtle things which require a little investigation.
Okay, so while Tom was going on over there, I put another job in that I had pre-selected. This one to show other things. This is another Stampede job, and the accounting data. Let's just look at that one job here. The data on this is a different pattern. You can see here again the CPU balance is not good. The homogeneity now is awful. In other words, the job did not execute uniformly for the L1 D-cache loads throughout its time range. And the interesting thing about this job is that the CPU user doesn't look all that bad. It's 90%. That you would think, well, maybe that's not so bad a job, but it's got its problems. If you look at the accounting data on it, it happens again to be another 256 core job. It's run on 16 nodes. This one is running for, let's see if I can find it. This one was running for almost 2 days. And what happened is after 2 days, if you look at the status here, the exit status, the user killed the job because obviously I guess he was expecting it to run more quickly, and the thing kept going on for 2 days, and probably he didn't understand or know what was going on. To look at some of the other information here, the executable, it looks like this was a NAMD job. We can see that from the executable, and I'm not going to look at go through the summary metrics or the detail metrics, but let's just look at the user. CPU user. So the interesting thing about this job is you can see what's happening is it's going along and it ran for several hours and suddenly one of these nodes dropped out. Node 461804 suddenly died. For 61804. Here we go. All the cores on that guy died. All the other nodes appear to have been okay. Okay, so let's look at what's going on in the memory in this case. The memory bandwidth here at this point suddenly drops down to 0. And the most telling thing here, if you look at the memory usage. What happened was it looks like the job was running and it was using more memory, and then it hit the stops here, and the node that sort of ran out of memory went down to 0. So this job was probably just sitting here, and I don't know what it was doing. It probably wasn't doing anything that the user was very interested in. So this is a good case where if you look at this, you can determine what happened. Now maybe the user needed more memory, or maybe the user had some kind of a memory issue that they but this is a good tool to give you information as to what was going on with the job. Okay, so those are the two that I had planned on doing. Next, I'd like to just go and do some other stuff that shows how to do searches in the job viewer. So we've kind of gone through and showed you the kind of general things that you can spot. We can go into a lot more detail on that, but that's not what I'm trying to do today. I'm just trying to show you that this is a tool that provides some information and how the job performs, and give you a little bit of a feel for how one might go about using this tool in your daily job flow.
The other thing that I glossed over in my presentation was that we're in the process of hopefully developing a user report card. So you'd be able, at your institution, you'd have report cards for users, and you'd be able to, and it would compare them to kind of the average in their particular discipline, or we're not sure exactly how it will be fleshed out. But the idea would be you could look at a report card for a given user and see if they're doing really well and they're getting high efficiency on the machine, then don't probably have to invest too much time in them. But if it's a user that has a poor report card, you might want to spend time and do a little remedial work with them. So that's on the horizon. I failed to mention that in my overview.
Yeah, I mean, while you've mentioned that, I should point out, I thought I'd be pointing it out more frequently even, this is very much the work in progress. We're putting in new metrics as we speak. We're changing the way we display things, and we're adding a lot of features to the whole thing, especially the job viewer, which has not been under active development for as long as the rest of XDMOD. So we're looking for feedback on it, how to use it, what people would find useful in it, and in addition to doing a lot of proactive development on our own. Next, I'd like to show you how to do an advanced search, and I'm going to select the start date here so that I can change that start date. I can change the end date or whatever. So now I'm going to do an advanced search on let's see, from the last couple of months, and I thought I'd do I try to pick out all the jobs for by user institution, and there's a lot of institutes that are running in Exceed, and we have the whole list of them here. Anybody who's ever run a job is in this list, and I was going to pick SDSC because I know that's a pretty good size. If I can find it. SDSC, okay.
Type in search box.
Yes, okay. Joe is pointing out that I'm being very clumsy here. That you can type in a search, and it autofills. However, I'm going to add that anyway, and then I can select other criteria, and you usually will want to select source criteria. And this time I'm going to add. I'm going to get some jobs. I want job wall times that are longer, because if you only have a short job time, short times aren't usually as interesting. You only get a few data points, And so I want to take the long jobs.
You also avoid failed jobs.
Yeah,
If you don't put a criterion like the job length, you'll get all the failed jobs too.
Yeah. I'm stacking the deck here. Let's face it. And then I wanted to show you also that I can add, multiple criteria. In this case, I've added the job wall times for 18 plus hours and the job wall times for 10 to 18 hours. A given time range there. Now, if I hit the search button, I should come up with some jobs. In this case, I did a bunch of jobs. I'll select some of these jobs if I wanted to look at them. Let's take some random selection here. And these I haven't really particularly vetted, so it's more just to show you how to do the search. So I have chosen to pick a few of these jobs from this table. I could have picked all of them or one of them, whatever. Save results, and now you can see those 3 jobs over here now appear in my search tree history, and I can now click on these guys and display them. So this happens to be a Comet job. It was run on 384 cores, 16 nodes. It's a Python job. Exit status failed. Oops. So much for that, Tom. And it ran for 18 hours.
I just meant the jobs that just submit. There's a problem with the submit queue when they.
Yeah, right. Yeah. Let's see. So let's just look at it, see what they look like anyway. Well, you at least get an interesting looking one here. The CPU users there. Let's see what happens. What do we got here? One node. So. Okay, not sure what it's doing, but it's an interesting looking job. It's not doing much, but try another node just for fun. Okay, well, it's consistent, whatever it is. Do a quick look at the memory. All right. And let's continue on here with this. Look at a couple more of these jobs and see what's going on with them. Okay, well this one's a more normal looking job, I guess. Be more consistent throughout its time frame. Anyway, the whole point was just to look at, just to do a different search. And one other thing I'd like to do is show you how you can do searches with the from the Metric Explorer. Let's see. We already made this plot. Oh, by the way, I promised you to show you how to do a report generator plot. I forgot to do that. Well, we can just still do it now. How much time have I got left there?
You're already at 45, so why don't you do it Metric Explorer?
All right, I'll skip that. If you wanted to do a report generator report, all you do is click this box here, available for report. You'd click on the report generator and that tab, and that sends you to the report generator, and I could output that report, and I could then send it to myself in email, and it could be done periodically if I wanted, or I can just do it for one time. But I'll skip that for the moment. And let's go through a workflow that you might do with if you were trying to narrow down jobs and look at different things. Already we have chosen jobs by institute. I can now click on this particular. Can I click on that? There it is. And drill down there, and I can look at, say, CPU user value. So now I'm looking at all the jobs from MIT that were in that time frame, and now this is the CPU user value on them. They're out of order because they're done by. There's two ways you can sort these. Basically, you can sort them by how many jobs you have in each category, or you can sort them by the CPU user value. Actually, this is not a bad way to do it because you can see most of them are in the better than 90% jobs, so 90% CPU user. So these are the good jobs. These are the ones that are efficient. But it's no fun to look at those. Let's look at some of the ones that are the poor jobs. So I can click on this less than 10%, and I can show the raw data on that. And now I'm going to get, if I do that, I've got a bunch of jobs. Now suppose I wanted to do, I can do further on this, and you can say, well, I don't really want to look at all of them because there might be a lot of short ones or something like that. I can add a filter to this, and suppose I want to filter by wall time. And let's look at the long ones, the 10+ hour ones. I can click on that, and now I'm going to get the long ones. And interestingly enough, the jobs that are running a long time seem to be the good ones, and most of them now are in this category, in the 90+ user CPU user. But there's a few in here in this other one. A bunch of jobs there that didn't quite make the grade. And let's pick one. And we can click on that Show Jobs. We can pick that, and that automatically sends it to the job viewer. So anyway, there it is. And that's another way to locate the job. And we could go through and examine that job, but I don't see any reason to beat a dead horse here. And we're also getting close to the end of time, and want to give you guys a chance to ask some questions if you have them. But let me go back and make one last pitch here, which is to what we're going to do here. We're going to be at XSEED 16, and we've got a bunch of presentations that our group is going to be doing. And in particular, I'd like to highlight two of them. On Monday from 1 to 5, we're going to be giving a job viewer tutorial, and that's going to be highlighted by Joe and Tom going into a lot more detail. And we're going to have 4 hours to present it instead of this just quick overview that I was able to give here. And also on Tuesday, we're presenting a job viewer poster. We're going to be around the whole length of the XSEED 16, so we'll be available to talk to people and answer your questions, or if you have any questions, or you wanted to learn more about the job viewer, or the XDMOD in general. And with that, I'll just throw up in for questions.
I'll just add, Bob, that it's a lot to go over in an hour, and it looks sometimes it can be intimidating because there's a lot of features. It's like any interface. The more you add to the capability to the interface, it becomes a little bit more complex. But in addition to the tutorial at XSEED, and I hope most of you will be there and you can attend, we offer one-on-one type training. We can have somebody come to your institution, show you. Can have a separate WebEx for longer and detailed. But the best way is to log in and try it out, and then you'll have used it and you'll have questions about how do you do this and how do you do that.
Okay, so it looks like somebody has actually asked a question here.
And how to set up XDMOD on a local cluster.
Well, the quickest answer to that is as part of the tutorial that we're going to do at XSEED, we're going to go through an install. So that might be the easiest way to get information. Other than that, if you go to the actual OpenXDMOD website, which is type in OpenXDMOD into the search engine and it will be the first result, there's fairly comprehensive installation instructions, and then we also have a mailing list on there that you can ask questions on as well. That would probably be the starting point.
And so we've had a lot of folks install OpenXDMOD, and only since December have we installed the job level performance type capability in XDMOD. So a lot of users have installed it in the past and been using it pretty frequently, and since December though, quite a few more users have downloaded. They're just now starting to install the version that allows job level performance. That requires additional installations of some sort of monitoring framework, so whether it's tax stats or PCP, and that's another level of installation. But again, we've helped users. Other users have managed to do that successfully, are collecting job level data in addition to the normal usage data. You don't have to turn on the job level performance. You don't have to install those things. You can use it just for usage, which is very valuable. You can look at things like how long are your queue wait times, what is your job size distribution. After all, it's a parallel machine with a pretty expensive fabric, communications fabric, so you want to make sure that it's not dominated by single processor jobs, and you can change the queuing parameters then to try to favor the bigger jobs. So anyway, we've been using it for years here without job level performance data, and now we do have the job level performance data. So it's pretty easy to install. The monitoring framework requires a little bit more sophistication, but we're available to help with pretty much every step. And then there's another question: is there a non-web-based API through which I can use XDMOD?
Yes and no. So everything you saw today was was running in the web browser, and it was communicating over a REST interface to retrieve the data from our servers. And you can reuse those REST calls, but they're not publicly documented, as in they're sort of integrated into our system. So we have no publicly documented external REST API. However, you can write tools that can query the REST endpoints directly if you choose to.
Any other questions? I'll ask a question. Are a good portion of you going to the XSEED meeting in Miami?
Tom, I can answer. There's about 100 champions that are going to be at the XSEED meeting. Hopefully some of them will be looking you guys up while they're there.
Yeah, the tutorial really last time we did it, I think it was at the XSEED last year, right? It really went well. We did a basic, Steve Gallo got up there and showed in shorter order how you can install it. He actually did a install there, and it didn't take very long. And that was the non-job level one. But anyway, we'll do an install, and then we'll do a hands-on type demo there where we'll show you and you can ask questions. And it's always better in person than it is. But like I said, it's a lot to digest. If you start if you have an XSEED portal account, you can actually get on and start looking at the XSEED version of XDMOD, and you can poke around and try different things. And then, I'd really recommend that. So if you are going to come to the tutorial, you've had some experience with it, and so that you'll have, better experience with it. You'll have questions that, well, geez, how do I do this? How did you do that? You'll see little tricks of the trade. I always learn things at the tutorial because these guys put in stuff that I don't know I have any idea, shortcuts, and they never bother to tell me, and then I see them going through making clicks here and there, and I realize that it could have saved me a lot of time had I paid attention to what they were doing. Anyway, so Like I said, I highly recommend it, but if you're going to do it to get the most out of it, I just get on. If you have an Exceed portal account, get on and just experiment around with it. You know, spend an hour and see. And if you have any questions, you can always get back to Bob, myself, or we should have put our email addresses. We can send that to Kay.
Right, and your email addresses were on the announcement that I sent to the champions in general as well. So, but we'll forward that on to them again so they have it.
Yeah. Once again, as Tom says, we support this product very heavily. So, anything you need, we can get back to you, and we help users on it all the time.
$1 million?
What's that?
You said anything I need. I thought maybe $1 million might be in your bucket someplace.
Oh. It seems a little low. I think you need to aim higher.
Okay.
It's on its way, Kay. It's on its way.
Well, hey, we're really glad that you took the time to be with us today. Thank you very much for everybody at University of Buffalo for being on. This is a great presentation, and I hope many of us will hook up again at the annual meeting. So thank you.
Yeah, and like I said, I think you'll find, especially if you have an on-premise resource on your campus, it's worth the investment in time, the amount of information. We use it all the time for simple things like we have tours of visiting faculty members who are considering coming here, candidates, and they'll want to know, oh yeah, what are the queue wait times, you know, because I'm going to come here and my job's just going to sit in the queue forever. I'll sit them down in front of the computer and I'll just say, okay, I'll open up XDMOD and I'll show what they were in the last week, or I'll email him a snapshot of what the queue wait times were for the past week, those sorts of things. Sometimes we have users that feel they're not getting a fair share of the computer and they want to know why their jobs are taking longer to run, and we can show their utilization relative to other people's utilizations. You know, I'm a center director too. We run a center here at the university, and we provide a really useful service, and we want it to be as transparent as possible. This interface is available to all our users. They can log on there and they can see a fair amount of information. So I think HPC centers in general provide a very useful and good service to the end users, and anything you can do to make it transparent to how good a service you're providing, I think is beneficial to you in the long run. And I'll stop my long-winded speech, but we'd hope to see you at the Exceed 16 meeting.
Thank you, and I will post a recording of this session so others can view it too. So thank you very much again. Appreciate it.